I did it.
All right. So, good morning, everybody. So, thanks for making time for this meeting. I'm glad you took this opportunity because otherwise you would be paying individually to get this training. And I decided to join in because I have a few trainers on the call.
Yeah,
And Brian and Scott, you will probably be seeing a lot of them in the future
whatever I do here.
because they'll get into the training.
Yep.
So, as Dave suggested, just for everybody's benefit, what is MPTS technology is very important to start off with. And this slide here kind of explains everything. Let's start with this logo here. It says Maximum Power Transfer Solution, which is the abbreviation or the acronym is MPTS. It is the next generation complete power management and power quality solution. If you have any questions with that particular statement, please go ahead and ask me a question. Pitch in any time. It's more, I would like it to be more a conversation and a workshop with discussion because one person's question can help everybody on the call. So a little bit of elaboration on MPTS is it's a clean energy technology. It reduces carbon emissions, it decreases operating costs, and we added energy savings because the byproduct of this technology and what it does to improve power quality also saves energy. Now, this technology is based on maximum power transfer theorem, which was written by Jacobi in 1840. Today, it's called Jacobi's law because there is a technology based on that science. When it is science and it is not converted into a device, it still remains a theorem and a hypothesis or just something that somebody is saying that will happen. And the reason why they no longer call it a theorem, it's called Jacobi's law, is there is a product that can now use the science, the theorem, and do things on the field. So there are three things associated with the technology as vetted and is included in the due diligence process of Underwriters Laboratory, the United States Air Force, and any engineering firm. The first step is what is the science behind any product? Is there one? Or is it just some product, snake oil, as you call it, or a black box? So that is the first step. So is there science behind any product? Number two, how does that science get converted into technology? Number three, now what are the functional aspects of that? So that is the sequence in which any engineer or any technical person or any decision maker should follow when vetting a product. Most people jump straight into, can I save utility bills? Now, that is a little bit premature. It's like saying, hey, how many kids can I have? And you're only 7 years old, right? So you got to wait your turn to get to that point. So this is a little bit of introduction, and this is the only known device that can be installed in an electrical network that saves you energy or carbon emissions or removes the problem without adding or removing or replacing any equipment in your network. I want to ask you a question and I want you to answer it. When you say lighting retrofit, what do you do?
You completely remove the old technology or the lighting and replace it with new lighting.
So you threw away an asset that was already working and you replaced it. What do you do when you want to increase the efficiency of, say, connected equipment? You just say, hey, this is old and it is running at only 50 or 60% power factor. What do you have to do? Brian, you can keep doing that because I think you are in the motor lab.
Yes, I'm actually in my studio, but what you have to do is you completely replace a piece of equipment.
You just say that, hey, this is old, it is inefficient, even though it can work for another 10 years, let's replace it so that the next one won't last you even 7 years. And reduce that life further by adding a VFD on it. And reduce it further by adding a motor control center, because now you just complicated that whole solution. So motors, you will see the new generation motors, compressors, chillers, rooftop units, split units, air conditioners, anything does not even last 10 years or 15 years today, which used to last forever.
Made in China.
No, it doesn't matter where it is made, because right now we have refrigerators, we have Maytag, we have microwave ovens, and I have the products that were made, purchased by my father and grandfather that are still in our homes. But whatever I buy, I have already replaced it in my own lifetime. All right. Any questions on the introduction of MPTS technology? It is now recommended for grid resiliency by Department of Energy, because they want every electrical network to be a resilient network, because the weather is hot, is becoming hotter, and the weather disasters are increasing, and they don't want businesses or homes to be without electricity, because it hurts the economy and the progress of the country. Therefore, they are now encouraging sustainable electrical networks. So you no longer will see 15-minute battery systems or storages. You're going to see weeks or months, or it should run indefinitely, because when the power goes down and the utility cannot restore it due to a weather-related disaster, they don't want businesses and economy to suffer. Dave, you want to add anything to the introduction of MPTS? Did I miss something out?
Well, I know everybody else kind of knows a little bit more about the MPTS. I know Jonathan's brand new to it, and so he's trying to get his head around this. Jonathan, was that it? Is there any questions you have about the MPTS technology itself at this point?
No, not right now.
Okay. Well, just to kind of put it in a nutshell, Jonathan, the system basically mitigates all power quality issues in the system on the fly. Plus, it'll save about 20% of the power, because power is being wasted in many different ways, but mainly because of the motor inefficiencies. The best motor found typically in HVAC is about 0.82 efficient. So that means you got about 18% of efficiency being wasted. Our system takes it all the way to basically 1, and that means all motors within that circuit. So the combination of saving power and also mitigating all power quality issues is what this system does. Okay.
Thank you, Dave. That was actually a very good summary. MPTS is a dynamic solution which is adjusting to changing load conditions. That's another thing that you don't have in this world. When you have a solution, it is custom designed to solve a particular problem. MPTS deals with all problems in real time, and it's adjusting to off-peak, on-peak, on average load conditions. So, and it's a universal product that is not custom designed. It can be installed anywhere, whether it's commercial, industrial, pumping station, school building, just a motor load or compressor load or a refrigeration load, grocery store. So it can be installed anywhere. So the box is universal. You just decide how many MPTS devices you need to install in an electrical network. We'll probably get to that as a part of the installation.
And I want to say one more thing here also. Since we're dropping the power by about 20%, the load about 20%, that 20% basically is killing the equipment on the circuit, because it heats up by about 30% more than it would before when it's in. Our system will drop the heat within the system by about 30%. So what that means is you get less breakdowns, your equipment lasts longer. These are things that are kind of hidden they're not as obvious as a power savings on an electric bill, but they're probably more important from a point of view of overall cost savings. So that's another issue that should be mentioned. Anyway,
All right. Well, power quality improvement is what Dave described.
Hmm.
Think of your truck that you drive. If you use the old oil in your motor, that motor has to be serviced or the oil needs to be cleaned out every 3,000 miles.
it's a good one. That's
If
good.
you use the synthetic oil in that motor, that is going to help that motor not change any oil for at least 10,000 miles. And in the case of Cadillac and some of the high-end cars, you can change oils once in 100,000 miles. So, and it increases the life of that motor. That's one analogy for power quality improvement, which is if you treat the oil as one of the ingredients to run your truck. The second is your gasoline you put in the car, in the truck. If you put clean gasoline, your motor gives better miles per gallon. That's where your savings comes into play. In buildings, electricity is the fuel that runs everything. So if you have clean electricity, it's like having clean fuel in your car. It gives you more miles per gallon. So that is where you get the energy savings. It's a byproduct of putting in clean fuel in the building and removing all the dirty power from the building. I think, Dave, you got it to a point. Hopefully, that's a good starting point.
Yes, I think we get a good overview. Yeah, from the point of view.
So this equipment is now, we have to have this in every installation and on the units itself because it operates in high volt or medium voltage, 208 volts and 480 volts. A trained technician is recommended for installation so that they can install it safely. So it's always safety first when you're touching anything that has electricity because it can cause danger and a hazard to both people installing it or not installing it or in the building, and it could even set fire to the building if you don't know what to do. Basically, this is a 21st century quality improvement because it couldn't exist. Your science could not be converted into technology until the 4 megahertz chip was invented. So this solution is aimed at being closest to the problem producing load, like high energy consuming load, high harmonic emitting load, or the most inefficient load. So you can install MPTS at several points. So this picture is just telling you, install it there so you contain the problem closest to the load, either the load disconnect switch or the sub panel, or you can install it on the load panel. And what it does is it's also removing all the dirty power, and that's how it improves the efficiency. This installation manual is written for qualified and licensed personnel. It is a guideline for installation, commissioning, and maintenance and troubleshooting. So all this information is available in this manual. After going through this manual, you can be more confident. That way you're not imagining what it is because you get to see pictures and actual connections and actual units. So the purpose of this is to guide you to install it in 2 hours. Okay. So it's that simple. If you don't know and don't go through this training, you could install it in a whole day or 2 days or a whole week and still not be able to commission it because something was not done right. General overview is basically you need to understand that MPTS can be installed on switchgear and it takes care of voltage fluctuations. It reduces the total power required to run the same thing. And as Dave pointed out, it lowers the heating of the switchgear or transformers or motors. And that is what protects the equipment and increases the life of this equipment. Utilities have to design their distribution network to provide for the electrical demand and make provisions in the capacity for inefficient equipment. This is where the demand charges are affected when you install MPTS, because they have to provide a transformer and maintain the peak load anticipated from your building. And that affects the carbon emissions. And that is a quick overview on why MPTS is being pushed and preferred by utilities. This is a good checklist. So when MPTS is received at a facility, you want to make sure that you have this checklist with you and you want to check all these points here. Circle one of them. It's made very easy. The reason for this is if there is any kind of external damage, you want to make sure you note it. Because if there is some external damage, you don't know the extent of damage inside the MPTS. Write down on the delivery paperwork from your UPS or FedEx or your freight carrier that, because when you sign that delivery note, they have fine print that says received shipment in good condition. So you want to write down received shipment with external damage, will confirm internal damage after unpackaging, because most times when equipment is delivered, it is received by the receiving department and it may not be opened immediately. So if there is any damage, please arrange to open the crate immediately to evaluate any damage to the equipment inside. This is important because if you have to report any damage, this has to be done within 24 hours. Keep a copy of the signed document that you signed off with these comments. Otherwise, you cannot claim insurance, and either the contractor or the customer is responsible for that unit, and this unit is not inexpensive. It's a very expensive piece of equipment. Freight insurance can cover it, or the customer's insurance can cover it, or the contractor's insurance can cover it. But if you don't have proper documentation that the damage was there when you received the shipment, all that insurance will not pay for it. So this is how it is going to be shipped. Every unit is tested by UL, CSA, or Intratech, and they put a label on the unit itself before it is packaged. Then the carpenters come in and first place the MPTS on a pallet, bolt it down, and build the crate around it. And the last thing that goes is the roof of this crate. And then they strap it and all that. And it's ready for shipment to withstand whatever the shipping companies, the forklifts, or the forklift handlers do, including this damage you can see. If you see something like this, maybe the unit is damaged inside, maybe it is not, but you got to make a note on that receiving checklist that you have and on the paperwork provided by the driver of the truck. Any questions? So when it comes, make sure that you have the ability to offload the unit, because the smallest unit weighs like 900 pounds. And this unit here is probably 2,000 pounds or 2,300 with the crate. You may need a forklift, or you need a truck that has a lift gate to drop it on the ground. And then you'll need a dolly that can carry that, and you can roll it to your warehouse wherever you want to place it, or take it straight to the electrical. Question? Self-explanatory. So unloading, unpackaging, and then there is an option for you to put it on casters, because sometimes the crate is too broad and may not go through doorways to take it to the electrical room. So you can remove the crating around the unit and you can put it on wheels. So it is better to do it right when you have the forklift, because this is what it's going to look like when you remove the bolts. Start at the top, remove the bolts that's holding the top of the crate, remove the top, and then you remove the bolts on the side and remove the sides off. It'll look like this. It is still sitting on a pallet. You could raise it and you could install your casters or wheels underneath the MPTS, and then you can roll it down, and you can even leave it on the wheels, because then you don't need bolts in the concrete. You don't need vibration pads to bolt it to the ground. And this is very good, especially when you're installing it in tight places. When any device is on wheels and you have a flexible conduit bringing it, the inspector will not worry or bother you about clearances around the unit, because you should be able to move that MPTS unit to have the clearance required to open the front panel or the side panels. Brian, any questions?
Yeah, I do have a question about that, Adil. So it sounds very convenient to keep it on casters. And my question is, you've never had an inspector question the movement of the equipment during short circuit current faults?
You will see why they don't question it, because you'll see how it is connected and how it is installed. So it is robust. Once it is installed, even if you move it around, it is very hard, if it is installed correctly, to generate any loose connections. That's a very good question, because that's why crimping, clamping, and bolting the wires is so important. You'll see that. This quickly gives you the dimensions and the weight, so that before it arrives.
Adil,
Yeah.
good morning. This is Chad.
Very good
I have a
morning.
question on the casters
Yes.
for installations in California. Have you ever had an inspector or some AHJ say no on the casters due to seismic reasons?
Yes. Yes. You bring up a very good point. In places where you have the local law overrides the IEEE or the NEC codes. So OSHA, not OSHA, OSHPD in California requires all equipment to be firmly bolted on the ground. Even though there are pilot projects and due diligence projects in California that have been installed on lockable casters, where all the wheels have to have locks and you have to lock it. And once you do that, and then you need conduits. So the conduit itself prevents the MPTS from rolling away, rolling down, or whatever. But in California, general practice, you are not allowed to keep it on wheels. Good question.
Okay, thank you.
Yeah. So these are the dimensions and weights. This could change. There could be a few inch variations here and there, because upgrades happen with every batch that could be produced. Usually you don't make changes, or you make changes only once in 2 years to important physical parameters of the units. So this has been the size now since 2017, but Chad installed a few units and we adjusted these dimensions, because the first unit, the manual said 28 inches. So Chad, we have upgraded this manual based on several of your inputs. So you will see that, because Chad has purchased, designed, and had it installed in several of his projects. And this used to be 28 inches wide. And when it arrived there, it was 31 inches something. So it is now built to be 32 inches, so that it can go through a 36-inch doorway, because the clearance is only 34 inches in that door. Even this 36-inch units can go through the 36-inch door, because I think in reality it is only 34 inches. So if it is a straight push through into the door, you can actually push it through a 36-inch door, even the big units. Questions? This is a specification sheet for all the units that I just showed you in the previous slide. And basically the MPT, there's one more model called MPTS 120. And that is now under special manufacture. It is not produced during normal production batches, because we noticed that most of the panels and the loads, the minimum panel is 200 or 225 amps. It could be 400 amps. It could be 600 amps, but very rarely you have a 100 amp panel. And even if you have a 100 amp panel, the load is only 30 amps because that panel is over designed and oversized to deal with all the electronic and voltage variations to avoid tripping. Therefore, it doesn't show up here because you may not need it unless you have a discount tire or Chick-fil-A or a McDonald's or something that has less than 100 kVAR and something that has less than 120 amp load at the peak.
What's the voltage on that? What's the voltage?
480 volts, three-phase.
480?
And you could also get 208. All these units are available in both 480 and 208. 208 also is another one that went into special production against orders. It is no longer made because 480 volt units fulfill more than 90% of the orders that come in. I think Chad knows this by heart. So any questions on this, Chad? You have a very observant eye, being a design engineer and a developer. And
I don't,
anybody else?
I'm not an expert at Dale, but I always learn something.
The important question here is the 3-wire and 4-wire, okay? So earlier the units were only 4-wire. They did not work on a 3-wire system. We started finding out, just like Nevada Corrections or several customers that we visited when we were there in California, Nevada, Arizona, and even in Dallas, Texas, brand new buildings. The designers are still building design because the senior design electrical engineer happens to be in the field for more than 30 years or more than 25 years. And people get used to doing things the way they did when they learned it. So they're not paying attention to the changes that have happened in the last 10 to 20 years in the buildings. If you don't have a neutral and a ground in a building, you already laid foundation for a very expensive operating cost for that building. That's a whole different certification training. We will talk about that. Carl delivers that training and uses this IEEE book on grounding. I have, Transpower has a course on why is neutral and ground wire needed in buildings today. And that is a very important certification program for all electricians, all design engineers, and all maintenance staff and crews, because half the things they wake up to every morning is related to a bad ground or no neutral or bad connections of neutral and ground, and all faults and service that people like John from Intermountain have to pull their hair is to deal with the same problem every week or every month or every year. They'll never go away. It's like if you don't take care of the basic design and installation, you laid foundation for ongoing problems. It becomes a chronic problem. MPTS has built it short circuit, overload protection. It has the metering. It has more metering than the utility meters or the utility smart meters can actually even comprehend. So this is actually taking care of a lot of things. And it is an automatic switching based on load requirements, which means you don't need software people, you don't need IT, you don't need programmers to touch the MPTS or do anything with it. It is pre-programmed, it is self-learning, it is built so that once you turn it on, you leave it alone for the next 30 years. You should have a copy of this because it pretty much covers a lot of detail.
Just took a picture of it.
Now, this is a cut sheet on each unit. So it just goes over, because sometimes the electricians or project managers want this. It's a ready reference to quickly have some information. And these are part of the cut sheets. This one, And this one, so when you're dealing with 240, you don't need the entire installation manual. You just need to have these 3 pages or 2 pages here, and then it has a connection diagram it gives you. So basic 3 pages will take care of it. Safety measures, we go over safety measures several times just to emphasize, and it makes sure that when you receive a unit, you want to open the panels. All the panels, there are 3 sides that can be opened. Mostly the front and the right side is what you need to open. That's where most of the connections and the work needs to be done. On the left-hand side, you have the harmonic sync assembly, which you will see it. I will show it to you. And that it's good to open it and look at it, but you don't really have to open that side at all. Check for loose connections in transit. Check for anything that is short circuiting or fallen, like when they're packaging or when they're finishing. If something fell, some nail or whatever, you never know. But every unit was tested. It's not batch testing that happens. So you need to take the usual precautions that electricians learned. And the project manager needs to make sure that he is supervising the electrician so that they go through the steps, because it takes less than 20 minutes. That can save you 20 weeks of troubleshooting or fixing what you ignored. That 20 minutes is the most expensive 20 minutes for you if there is a problem. Question. So this clearly defines what is it that you want to check. Usually there is called a, Brian, what do you use when you want to simply connect a device? What is the instrument called that you connect to check all the circuits for short circuit, for resistance, your ohms?
You would be using your test meter or multimeter to verify. I did see on that prior slide, you had a mention to go ahead and measure the electrical parameters to ensure that the unit is properly sized. With that, I know that's a lot in the pre-planning and design, but it is probably wise to make sure you actually measure the power coming into your facility prior to the purchasing and planning of the installation.
You hit
Absolutely.
the nail on the head, yeah.
But you might
Sizing,
need more.
yeah.
You might need more than one of them.
Yeah.
So it depends.
There is a reason why you want to do this as soon as, because there are certain checks you cannot do once you connect the wires. John, you must be familiar with that. You want to check short circuit connections, loose connections, all that before you make the connections. Otherwise, your multimeter, your megameter, Megatron, there are sophisticated instruments that people like Sturgeon Electric and IME, they just go connected. John, I want more participation from you because you are actually on the field and you want to shoot any question you have and share any information on what training IME has already given you or what you went through in your journeyman or your master electrician training. So it's very important because you cannot check a lot of things after you have connected, because now the electrical wiring in your building becomes part of the MPTS wiring. So when you get a short circuit or when you get the ohms that you shouldn't have, you don't know where it is coming from. Right, Brian?
That is correct. Yeah, you could be measuring through transformers if you were checking continuity between the MPTS terminals when they're already connected.
So it's very nicely detailed step by step. You probably use this. I recommend that the project manager has this on every installation and every time. But I notice electricians, after they've installed one, even in the first one, they don't have anything because they already know and say, hey, I know how to install it. There are certain things that happen outside the MPTS because your wires have to be not only connected inside the MPTS, you also have to connect it on the other side outside the MPTS. And one of the critical items is the sensing equipment, and it is called current transformers or CTs. And this slide describes how you install a CT. If this is the direction of the current flow inside your wire where you're installing the CT, you need to match the arrow on the CT with the direction of the flow of current. A is coming from the source, B is going to the load. So it's very important. And then C are the wires going to the MPTS, and they have the positive and negative. So the orientation is very important. CT cables to the MPTS. So mains power supply going to the load, very important. Chad has seen it, Dave has seen it, I have seen it. All of us have seen this donuts lying the wrong way on three phases. You have three phases. Sometimes two are lying this way and the third one is lying the other way. You know what I mean the other way? The sprinkles and the icing is at the bottom instead of the top. You have seen that, Brian. I see you smiling.
Yes, and everybody has seen some CTs put on reverse.
Negative.
It's
Negative
very
power.
obvious when you turn it on.
So
Right.
there are several types of CTs. You're saying that was a circular solid core CT. These are called split core, where you can put it around a bus bar or on a wire. We have avoided using, these are only installed in the factory, and these are installed used to be installed by electricians, and they would have a choice to do it. But then if they did that, they had to make sure it's exactly in the center of the window in the CD. So we no longer use this, but there are several units that have these. So you need to make sure that it stays like that. But we noticed that there are a lot of problems happening because of that. So we went to Rogowski coils, which is a rope CT, which is a snap-on CT, lot easier to install it across a group of cables on line A, line B, and line C, or line A, line B, line C, the bus bars. So you can use Rogowski coils or rope CTs. How many of everybody on this call may have already seen this, right? So it's not new to you. And these have a special characteristic because I have seen on some of the chats projects, they bought these CTs and they were, let's say they bought a 500 to 5 amp CTs, and on the side they realized that the peak currents are going to 600, 700 amps. Now they got to go buy those CTs again because they found that that CT won't do because the current is going up to 1000 amps. So what happens is when you buy one CT, install it and find out that it's not good, you got to go buy another CT. You can avoid such cases because this rope CT can handle up to 50,000 amps going through this bus bar. That is the reason why we have standardized all installation. So the electrical contractor will order this. Now, Dave has done one more thing because he's one of the reps that supplies the units. He includes the rope CTs and the metering that is outside the MPTS. He bundles it and quotes a price so that it's not left to the contractor to go find and buy some of these critical components.
Yes, it's called an AccuEnergy energy meter, and we have to fill out a sheet depending on the application, so that we can pre-program it and send it to you pre-programmed to make it easier for you to install. So that's kind of part and parcel now with the each MPTS.
So that form that Dave is talking about will ask you what is the diameter you need, the window you need in the rope series. Like you can see, they're coming in several sizes. And it is capable of handling four. This question is for John. John, you have seen cables coming from the utility going to the switchgear, and even Chad may have seen it. there could be as many as 12 to 14 cables on a single phase on a 4000 amp switchgear, and you need this big diameter to wrap around all the cables.
Seen it.
But if you have a bus bar, most of the times the smallest one is enough because it is built to take the width of the bus bar, but you cannot put the tightest one simply because of the space available for your hands to go through. You may be wearing your gloves, you may be having your hazard equipment, you're wearing your shield, your helmet. So sometimes it becomes, so you use a bigger size to make it convenient for you to send the Rogowski coil to wrap it around the bus bar, even though you don't need a big diameter. You may go to one size up or two sizes up to do it. Here are some examples to show what I meant. You see this width of this is a 5000 amp bus bar. These are 2000 amp or 1500 amp services coming from the utilities. Examples of the CTs, on the main bus bar. You want to find a very clear spot because these CTs need to go in at a particular spot, and you'll see that as we go through the slides. Any questions or problems that we have faced? Now, I want to share I like stories because we learn and remember stories. The hospital that was recently installed for MPTS H490 in Dallas, Texas, it is a hospital, okay? So they had to take a power shutdown, which means they had to fire up their generator. And then they installed this rope CTs on the bus bar. The electrician and the project manager and the people that were there decided to install this rope CTs on the other side of this bus bar because, generally speaking, putting a CT to measure what's happening on that bus bar does not matter because the current on this side of the bus bar is flowing all the way across the switchgear and is running through it. Guess what happened? You want to measure and catch the problems coming from the utility transformers. So you need to put one set, these CTs, or two sets of CTs actually. One set of CTs are going to the MPTS. Another set of CTs are going to the AccuEnergy meter. You'll see that in a minute. They need to be at the place where power comes into the building. And it is very important. So they took a power shutdown and installed it in the wrong place, and all the data we were getting was wrong because there's another set of CTs measuring the load on the hospital. So now both the CTs that they installed externally and the CTs inside the MPTS both have the same reading. So all the data you were gathering was the same from both sides. So MPTS thinks that there's nothing to do because it's a perfect condition.
Say that one more time, Adil.
Oh, this also was done by Pablo and his team on your projects in that school. And it took us 3 attempts and 3 power downs to correct that situation because the electrician installed the CT where it was convenient for him. He opened a switchgear panel and installed it. Maybe I have something I can show you.
What is it that we're trying to ensure that we don't do? Can you just say that again?
Yeah.
You state the problem.
Okay. When the power comes in like this on the left side, you see cables are coming here. These are coming in from the floor, from the utility transformer. Do you see this here? My mouse? Here. So the
Yes.
power coming into the building is coming from underground and it's coming in here. And you need the CTs to go, the external CTs that are being installed by the contractor has to go at the input of this. You can catch it at the cables. you open the bottom panel of the switchgear and you see the cables connecting to the bus bars, and you can wrap it around those cables.
Now, are these the AccuEnergy meters or are these the MPTS
Both, both,
CTs?
both,
Both. You put both in the same
yeah,
spot.
both CTs have to be here.
Okay. Maybe that's what I misunderstood. Thank you.
This is only showing one set of CTs because until last year or after COVID, we installed only one set of CTs and connected both the AccuEnergy meter and the MPTS from the same CTs because the same information is gathered that goes to both the meters.
So you're saying best practices has been altered to have two sets of CTs, one dedicated to the meter and one dedicated to the box.
That's correct.
Okay,
Ask me
that's the
why.
clarification I needed. Thank you.
Yeah, the reason is because this itself, the donuts are not placed properly. If you don't have a supervisor and he doesn't notice how the wires are coming out of this, the donuts may be placed the wrong way, this CTs. Even though it's a rope CT, you still need to know that one side has glazing and sprinkles on it, the other side doesn't. So they all
Polarity.
have to be
Polarity.
down the same way. So now we'll add another confusion if we have to walk them through how to connect the wires. So in order to make it quick, easy, and stop errors from happening, we install two sets of CTs. One goes to the AccuEnergy meter, one goes to the MPTS. Now you can catch this here and put it at the entrance, safest way, the best place, the easiest in many cases. Sometimes you can't access the cables because it's the bus bar that is coming in as shown here, because we installed the Bank of America building in April and the transformer is under the ground in the sidewalk on the street downtown, and the transformer is running bus bars horizontally straight into the basement where the switchgear is, and this is what is coming in. And if I was not there, they would have installed these rope CTs at a convenient point in that switchgear. I will show you that little later. Somebody make a note and ask me to show you a different case study so you can see the actual installation of one of the projects. I need to include that switchgear pictures at this point because it's easier to talk through when you're looking at a switchgear.
A deal. And what was the issue that you said that Pablo did?
Excuse me?
What was the issue that you said Pablo did on his installation?
Sorry.
The problem was at the installation at the schools. Did you add to unfold? What was
Okay.
again?
Yeah. So what happened was, you know, the switchgear, the reason I put in pictures here is the one line diagram makes it look too simple, right? Hold on. Did we see a one line yet or not yet? No, not yet. Javier, that's a very good question. What is the problem that we see, not just on yours? I just mentioned your projects because Chad is on it here.
Yeah, of course.
Yeah. You see this one line diagram? You have the main power coming here, and this could be coming from your main disconnect, or it could be coming from a transformer, and the power is coming in and it connects to the bus bars. And then on this bus bar, you're tapping the CTs.
Mm-hmm.
And then the point of coupling to take the power out is here, downstream of the CTs. And then all the load MCCBs on your switchgear are on the downstream of this point of common coupling. You guys have heard of the term POCC, point of common coupling?
Yes, please.
Yeah. So in one line diagram, it looks pretty clean and pretty simple. Let's go back to another diagram here. Yeah, see? This one line says utility meter, main disconnect, wire is coming in and it is going in like this. And then you're saying the power has to go to the MPTS through this breaker going to the MPTS, and the CT has to be upstream going from here. But you look at the switchgear. When you open the switchgear, it's not as clean as this. it looks like what we were looking at. Like this. You see what a mess it is? So what happens is when the wires are coming from the bottom, if you're able to, you're going to put it here. If you're not able to, you're going to go a little bit higher and you're going to put it on the bus bar. And if you're not able to put it here, the mistake that happens is they go way higher, but then you went past the point of common coupling. What happened is you installed it on this side.
Yeah.
Instead of it being here, you installed it here. So what happens when an error happens? You have CTs inside the MPTS tracking all the what's happening on the load side. It's already here. When you install these CTs here, both these CTs read the same.
Yeah, got it.
So this is a common mistake that happens in installations when people are not paying attention. They just say, oh, this bar is going from here to here anyway. How does it matter? It'll become a little bit clearer as I go through. Any more questions on this? So we had to ask for another shutdown and do it one more time. And there were 13 people involved in that shutdown because you needed the maintenance people, you needed the electrical contractor, which was Prism Electric. You needed a project management firm, which was Austin. We needed the MEP designers, which is a whole different firm. We had an architect's representative. We had the electrical engineer, Don Braswell, because whenever there's a shutdown of a factory, a lot of things can go down when you turn it back on. So it's not easy. So we got to do it right the first time. Just like Bank of America, 14-story building. We are going to be doing a 41-story building in Atlanta. Just imagine when you shut the power down to do this. Many times you don't need to shut the power down because if you open a panel at the bottom, if it is coming from the ground or if the cables are coming from the roof or the ceiling, you can actually catch all these cables which are already insulated, they're already protected, and you can actually put this in live. So you really don't need a power shutdown. In many cases, if you are able to catch it without going into the part where you have exposed terminations. We have installed this on 3000 amp live switchgear in 24-hour chemical plants and factories where they shut down the power only 4 times a year. You can't even ask for a shutdown. If you do a project, if you need a shutdown, you got to do it in that week when they shut down the power.
So Adil, I have a question. That's a very good example of how critical it is to ensure that the CTs are installed correctly the first time. The example you're highlighting here, you said there was 3 shutdowns to get the placement of the CTs correctly, and we all understand how expensive and time consuming that can get. What was the problem on the second placement of the CTs?
I'll show it to you. Hang on. That's very good. This is a good point for us to have this discussion. I'm pulling up another document.
So the first time that they made a mistake, what was the mistake they made first time? Was placement, where they placed it on the load side of the MPTS instead of the source side.
Correct.
So they figured out they made that mistake, and you go into shutdown number 2, where they again was it again misplacement or reversing of one of the CTs?
Yes. Okay. Let me share this with you. And keep the conversation going here, okay? Do you see this?
Yes, I see the piece of equipment and the one line.
Now, I want any of you or all of you to have a discussion on this document here that is also in the manual and was provided to them. So they had this, and this shows the transformers outside, the utility meter, the main disconnect switch. I think this is the main disconnect switch. And then you see the CTs, two sets of CTs. And then you have a point of common coupling for the MPTS. The green is the accu energy meter and the MPTS power management. And this is the power to the MPTS. Do you see the CTs? How they are placed?
Yeah, I do see how the CTs are placed. And of course it is, on the line side or source side of the
Point of common coupling. So now when you look at this as a switch gear, when I said the power is coming in from the utility from the bottom here, okay? What they did was they installed the CTs somewhere here. Actually, it's not even in this panel. It is on this panel here, the second row of the panels. And then you have this bus bar running horizontally and vertically. Goes up, goes that way, comes down, goes up, comes down, goes up. So it's running all over. So what happened was this CTs ended up in the first time he installed it here. Because see how easy it is? You open this panel and install it here. It is even past all the loads. The second time they did it, they installed it and squeezed it in. They squeezed it in on this panel, and they didn't realize that, see, this one is running this way and it's probably dropping down. So you're partially on the upstream side and partially you are on the downstream side. This was the third time we said your existing CTs that are here, the second time they installed it here, they need to be moved down here because there is a nice panel here below this main switchgear. It's coming in here. Either open this or open this and install it here. And that's what they did last month. So this unit was installed in December, and for 8 months, we didn't have power management data.
Yes, I could see how that mistake happens. So the emphasis is to make sure the CTs are installed correctly by someone that is familiar enough with the equipment and the flow of power from the utility.
Correct. Correct. That is a very important, that's a very important part of this discussion. Okay, I'm going to keep this open so it'll help with our continued discussion here. All right, now let's go back to our presentation or the manual. Where is that manual? We were here. So is it back?
Yep.
Yes, your presentation is back up.
Yeah. So now this takes you a little bit into detail, and this is the physical connections as you can see on the site. And now this is representing what happens when you install your CTs correctly here, here, and here. You got 2 wires coming out of each CT. So first I'm going to talk to you about the connections going to the MPTS. So you have 2 wires coming out of each CT. One is positive and one is negative. One is positive, one is negative. One is positive and one is negative. And you can see this here.
White and black.
So you can see there's an integrator kit that looks like, where is the integrator kit? Let me show you the integrator kit. I just saw it here. I need to stop this, I think, before I share a new one. Here we go. This is the most important part of the whole installation. Do you see something?
Yes, we see the integrator.
You see the integrator, but there's something in the background too. Basically, it's going to be 1, 2, 3. It comes in here. Now, this for whatever reason, I think this is built on European CE standards. So the line A is here, line B is here, line C is here. So this line A connections go here, line B goes here, line C goes here, and then you have line A, B, and C that goes inside the MPTS. There's a termination box. Let me show you that termination box. Do you see this? Line A, B, positive, negative coming into the integration, positive, negative going into this termination is inside the MPTS. All three phases. So it is made so simple, but this is where I didn't realize that it is not so simple, because it's very easy to mistake even though they're color coded, you can say brown, orange, yellow. People take the brown and install it here, and take the yellow. Usually a mistake doesn't happen, and the brown, orange, and yellow. Usually the yellow comes in this side on the top. So this is where you got to pay attention. So if I'm on the site when installation is happening, I usually make sure that I am watching the rope CTs where they are placed, the two wires that are coming out of the rope CTs, where they're connected into the integration kit, and from the integration kit where it goes. And I follow a process where you install one CT, connect it all the way here, install the second CT, connect it all the way here, install the third CTs, connect it all the way here, because I've been in too many installations that took weeks together to sort this out, because the people did not mark the positive, negative on the other end of the CTs. And you got 6 wires lying on the other side. I don't know. And they are all black and white, or they are the same color. They're all black or they're black and white. I don't know which one is which. Takes weeks together. There was one job where I had to make them take the wires from here, laid on the ground, all the way to where the switchgear goes, connect it, and then open one by one and put it through the conduit. That was a YMCA installation in Idaho, Dave.
Right. Yes, yeah.
I was not there during the installation, so that was, I had to do a FaceTime and had to lay it down, because fortunately the CTs and the units and the switchgear was in a huge electrical room, so it was not so bad, because it was not on a conduit going to a different room. It was in the same room. Any questions here?
Yeah, so I want to touch real quick on that integrator. When connecting to the integrator, you're saying we have to be cautious of specific instructions of the phase configuration on
Yes,
the input and the output side of the integrator.
correct.
Okay.
Because people, what happens is because you cannot take a shutdown, they will try to swap the wires like they do in the motors to change the direction. But anybody here can tell me why you shouldn't do that?
Why you should not rotate the phases to reverse a motor?
Yes,
Well, you're going to mix up the phase configuration of the system as far as color coding. Is that what you're looking for?
yes, you mentioned phase sequence. You are messing up the phase sequence on one side, and on the other side, you got two parts, right? These CTs, the expansion for a CT is current transformer. When you say current transformer, you have two sides, right? Two sets of coils. One is measuring what is the true power, like 700 amps, and then the second wire is picking up 5 amps. So when you just swap positive negative just because this was laying on the wrong side, or you had wrong connections done, you're actually messing up the functioning of the CT itself. Everybody's
No, I think I understand what you're saying there. So you've had instances where if somebody mixes up the positive or negative, or if they flip the CT in the reverse direction, that they thought they could just flip the two wires to reverse the CT.
correct.
When in fact CTs are designed with a specific polarity due to the nature of how they wrap the coil around the conductor.
Correct. Correct.
So emphasis on understanding what CT you have and also where to install it into the equipment is crucial to avoid those very painful shutdowns or repeat shutdowns that frustrate a lot of people involved.
Yeah. If you do it right first time, I told you, right? It's a 2-hour installation.
If you do it right.
If
the
you do
first
it
time.
right, it's a 2-hour installation. Otherwise, it could be 8 months and you still didn't get it right.
Okay. And I can see how it complicates things if the CTs are also customer supplied. And that is also why some of your distributors have opted to start choosing the CTs for the customers.
That's
So
exactly right.
so that they ensure that it is a CT that is capable and
Power.
will be
Power.
installed correctly.
Right on, Brian.
Did I share another screen?
Right now, I'm seeing the diagram that illustrates how to connect the integrator.
Yeah. So these are the CTs on the 3 phases. And then you have a brown wire and a white wire coming from each CT at the end. And then there is a shield. It's insulated. And there's a shield. So you have positive, negative shield, positive, negative shield, positive, negative shield. And most of the times I see people ignore the shield, which is nothing but like a ground wire, which is where the integrator kit is grounded. So you want to remove the static electricity from the shield of that cable insulation to be removed. So this is the part we were talking about as to how important it is that you got the brown connected to brown, orange connected to orange, yellow connected to orange. So boy, BOY. And then positive, negative is very important here. And then one more thing I didn't mention about the CT is you need 100 to 240 volts power. So you need a 120 volt power, positive, negative, and a ground to be connected here, line, neutral, and ground. To the integrator kit. Now this is on the side from the CTs in your switchgear coming to the integrator. This is how it looks. See, the brown, orange, yellow is backwards, right? Because the whole world is following right to left. Our code says left to right. So this is probably built to European standards. Therefore, the brown is on this side, orange and yellow, and you got to pay attention when you're pulling the thing out on the other side, make sure it is brown, orange, and yellow. This is your power. This is a power supply to the CT, 120 volts going in here. It's always on. The CT needs to be always on so that you are getting your power management data 24 hours a day, whether or not, as long as power is running in your switchgear, you should be getting power management data.
Very good. Adil, I can see from that picture when you zoomed in, it is probably important to note that those the phase configuration there is noted with the channel 1, channel 2, and channel 3 on that integrator.
Yeah. It's already there. Channel 1, channel 2, channel 3. Channel 1 is hidden. Channel 2. There's one more mistake that happens is, do you see the shield has not been connected, right? There's a third lug here. Have you noticed? In this particular job, the shield is ignored. The ground is ignored. So what happens is when you ignore this, sometimes the positive, negative, these two are here in the second and the third. So you're not even in the right place. There are 3 lugs. That's another mistake that happens. And you keep hunting for hours together to find it. Are we good? All right. So one more thing here that you need to notice, we use Rogowski coils so that you don't have to keep buying CTs again and again, because then it becomes very expensive, right? These CTs can get very expensive. You went and bought some CTs and they were wrong. That's why you use Rogowski coils, and that is why it is bundled. And people, the distributor or Graybar or Dave Parsons, wherever you're buying the equipment, they now supply this with, they bundle it and they're quoting a price. Sometimes the contractor says, no, I have CTs, I don't want you to supply it. And now you have a problem, because now you have another variation that they might do something and you don't know what happened. But these Rogowski coils, when you install it, because they're rated to go all the way up to 50,000 amps, you have dip switches on the integrator kit. What do you want to set it? Do you see this? These are the dip switches.
And all the settings for those dip switches would be detailed in the installation instructions for that integrator kit.
Yes, there is a separate manual just for the AccuEnergy installation, and you will see it detailed there. And you can also see it printed on the integrator kit itself. Do you see this? Positive, negative,
Sure,
positive, negative,
Yep.
positive, negative. And here there's another error that can happen. Look at this is backwards. Why is positive, negative interchanged? Positive is on the right At the bottom, the positive is on the left.
That's called a curveball in baseball.
That is called a trick question, just to make sure that the electrician is paying attention. So now here is the code, the dip switches. If you have 500 amps as your running current, maximum peak current you think that's going to come into your switch gear is 500 amps, you're going to set the dip switches on, off, 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 and on. So on, and everything else is off. Here, on and on, the last two, first and the last one, everything else is off. If you have 1000 amps going through, you don't have to go change the CTs. Hey, good luck. Now you just change, you saved a whole day because you already can just go change the dip switches. And now you can say on, off, off, on, off, on, off, off, on, off. Oh no, we got 2000 amps running through. Now you can go to 2500 amps and change the dip setting. Or we have 5000 amps, or we have 10,000 amps, 25,000 amps, 50,000 amps. Javier,
Yes.
you filled out 500 amps on your pre-programming sheet for AccuEnergy meter. So if you go beyond 500 amps, we want to remember that we got to go into that meter and the integrator kit and change that to 1000 amps. Go next level up.
Okay.
Technical support is available. So these are the CTs and those are the connections. And this is the wire. At the end of this wire, you can specify the lead length. How far away is your MPTS and the meter from the CT? Is it 30 feet, 45 feet, 60 feet, or 75 feet? So we can order it that way so that you don't have to splice them, because anytime you're dealing with sensor and low amps, you don't want to splice it, don't want to put connectors. In the hospital, they did put connectors, by the way, because they did it 3 times. Any questions on CTs and integrated kit connections? This is what you are asking for, Brian. Detailed instructions on how to connect it.
Yes, that
White
would
wire,
be
brown wire. Because another thing that is a mistake is you have brown wire as a positive depending upon the, like in the electrician world, brown is positive or white is always negative in the electrician world. But in the controls world, Brian may know it, Carl may know it, people who are in the controls, they know that brown is negative, white is positive. It's opposite. To differentiate between control wiring and power wiring, they have the color coding is different.
when I explain that to students, it is the common wire for power distribution. Everybody thinks is negative, common, neutral. As soon as you get into controls, common is generally source or hot, and that relates exactly to that conversation I always have.
Yes, you must, when you're training, spend the most amount of time on these connections. Everything else is a no-brainer. I thought this was a no-brainer because it's color-coded. You see, I even had to draw out, because I'm not there, I'm drawing on my notebook here that I always have with me, and then I'm sending it by text message, and I'm saying, can you please verify, because here is your brown, it needs to go to brown, orange, yellow, brown, orange, yellow, and then the brown flips over, it starts on this side and then it flips over. It's like, man, what's going on? It's not hard, it's just paying attention. Okay. Back again to our manual. So now, can we move on from the connections? And remember, you also could have a generator on site. And if you want to monitor what's happening there, or you want MPTS to also take care of some information from the generator, you can actually have another set coming into a place made for generators. It's right here on the termination. So this is an example where you have an automatic transfer switch. So if the power goes down, your generator comes on and you're on generator power, you're still getting all the measurements. That's fine. It's going to the MPTS, but you can actually also measure what's coming from the generator. So it's also there if it is required. I have not seen even one connected like this, except in maybe some data center or something like that, where they were using the generator in a bad neighborhood, where the power outages were more often. Otherwise, you don't need to worry about this. Is this clear now? The CTs have two wires coming out, and then your point of common coupling is here. And this power is what I showed here. Brown, orange, yellow, neutral, and ground. The ground should have been green, but they used a black wire. So power connections now. How do you connect power? Examples, right? You may have a breaker already in the switchgear that we use many times, but there's a breaker in the MPTS also. There's a 400 amp in the 240. There's a 800 amp in the 490, and there is a 1000 amp or 800 amp, a 400, 800, and what's the big one? 1000 amps on the big one. But you need a disconnect switch or you need a breaker in your switch gear to completely turn power off to the MPTS according to code. In many places, they have simply tapped power and connected it like I have shown you here. There is no disconnect switch. That is not the right way to do it. The right way to do it is, let's move to power connections now. Think of any questions or any issues or
Real quick, Adil, could you repeat what those breaker sizes were for the different models?
400, 800, and 1000.
Thank you. One more question I have about that, Adil. Previous in this presentation, you were saying how you had to lay out the wires in the electric room to get the CT polarities correct, because they were not using a raceway to mount the MPTS remotely. How far can you mount the MPTS from the point of common coupling?
I think Chad has an installation that was the farthest away. And I think, was that 300 feet or 150 feet?
150 feet?
Yeah, where they trenched the wire and took it out, Chad, on Cabrillo School District.
I don't know the exact lineal feet of wire. I didn't think it was 300 feet. It looked more like it was somewhere between 100 and 150 feet of lineal run. I try and, when I'm sighting them, I definitely try and keep it just directionally 75 feet or less, so that there's
75 feet or less. That is the
that's
code
what I
for
try and do.
controls. Yeah, that's right.
But the lineal run then gets to be a little dicey on how they actually run conduit and
Yeah,
where it's
the-
actually tied in. But I try and
Yeah.
keep physically, like I try and keep the box as close to the head of the switchgear as possible to keep the lineal run of conduit as short as possible.
Okay. No, that's good information that it doesn't have to be directly placed next to the service equipment. If space doesn't allow, you could find an adjacent space and then run a raceway to do point of common coupling.
Correct. Correct. Because MPTS has been installed under staircases. It is installed in storerooms. It's installed in computer rooms. It is installed somewhere else completely, like we did. But the recommended not to exceed is 75 feet, because if you are generating 5 amps at the source of the control wiring, you are dropping, you should increase the size of the wire if you're going farther away from that CT, so that you get 5 amps. What if you have only 1 amp coming on it? Because you have a 500 amp CT and you are only off peak, you're at 100 amps. So that 100 amps now is only at 1 amp at the source. And then MPTS is sitting 300 feet away. Does that 1 amp even reach the MPTS?
Yeah, and that was the nature of the question, understanding that, you know, voltage drop is one factor to consider. But as well with our knowledge of surge suppression, where you want your leads to your MOV to be as short and straight as possible.
As short and as straight as possible. That is a good statement to make. Okay, now let's share this other screen. Here is a very clean, fantastic installation, and I was there. We are talking about disconnect switches. This is a 5,000 amp or 3,000 amp switchgear. There are 2 switchgears. Can you see on the left-hand side? There's 1 switchgear here and 1 switchgear here. This is a redundant switchgear. Power comes in into both the switchgears, and then they have an interconnection so that the building is never, there's a data center, it's never without power. So what they did was they tapped the power at the right point, as I showed you in the other drawing, and brought it to this big disconnect switch. Do you see this angle iron that they built a framework here? Do you see this angle iron? Do you see
Yeah.
this?
We call that unistrut, Adil.
Yeah, unit strut, yes. That is the correct terminology. They have unit struts. They mounted it firmly around the MPTS, and then they brought the power into this disconnect switch. And from this disconnect switch, they took it inside the MPTS. From the top here, there is an opening. There is a cover there. You open it and you take it in from there, and the power is connected to the MPTS. And there's a 400 amp breaker here. That is the handle. So now there is another switchgear there. So that has another MPTS on the other side, and they have the same arrangement. And then the beautiful part of it is they place the integrator kit in a J box. Use the right terminology, Brian, correct me, keep me straight. So there's just an empty box that you use for splicing or connections. They actually installed the integrator kit inside that so that they could bring the CT wires and they could even look at the connections through a transparent cover. I don't know how they got that transparent cover, whether they custom made it or what, but this job is very well done. It is beautiful.
No, that does look like a clean installation, Adil. Uh, just to clarify, so they're using the disconnect switch as the required disconnect for that piece of equipment. Is that disconnect switch coming off of a circuit breaker, or did they do a direct bus tie for that installation?
That is a direct bus tie,
Okay.
direct bus tie.
And then the overcurrent protection in this particular case is in the MPTS.
MPTS has all the protections, and there is a fuses in this disconnect. They have fuses.
Okay, so it's a fuse disconnect.
It's a fused disconnect. That's why it's so big. Imagine that fuse, they're big. It's like, man, each fuse might be 40 pounds. I don't know, 20 pounds, 40 pounds. It's huge. So the reason why the inspector wants this is he's thinking, so far in the last 15 years, you have never removed an MP. No, I shouldn't say that. There is a case where we did remove it. But very rarely, once you install an MPTS in the last 15 years, you have removed one. You never remove an MPTS and take it away. But the inspector says, if you want to remove an MPTS, you got power here coming into this MPTS. How are you going to remove it if you don't shut the power off to the MPTS? That's why this disconnect switch or a MCCB in the switchgear is very important from the inspector point of view. He wants to be able to shut the power off to the complete MPTS.
And that is pretty typical in our area, is the inspectors are looking for some sort of disconnecting means for all equipment that is installed with the electrical system.
Yeah. So now we started this job at 4 o'clock in the morning. We met there. 5 o'clock, we went over the checklist steps. So we had to go up every floor to turn the sub panel off. And then we turned the switch gear off, main switch. Then the utility was outside at 6 o'clock. We had the power shutdown for this building. And by 12 noon, we had completed the tapping of the power to the disconnect switch, and from the disconnect switch to this. So we did all this for 2 units. One team or 2 guys were working on this side, 2 guys were working on the other side, and then 2 guys were working on the AccuEnergy metering. There's the AccuEnergy meter here. Do you see this? It's a little bit blur.
Yellow.
Yeah, the yellow stuff here. This one is the AccuEnergy. There's the integrator kit. So the CT wires are coming into this meter and into this integrator kit. And then from the integrator kit, it is going to the MPTS. Sorry, this is not a very clear picture. And then when you turn it on at 1 o'clock in the afternoon, this is what you saw. The power factor on both the switch gears, on one side, it is showing 1.00. The other one is showing 0.98.
Very good. So that was really good information, Adil. For a successful install of 2 units in one shutdown, you utilized 6 workers, 2 of them on each side, and then 2 of them doing the energy integrators.
That's a very good observation. How many teams do you need to get it done before the electricians start feeling sleepy, drowsy, or disinterested?
Oh, it's an essential part of any shutdown process, is understanding how many team members are you going to need on that team to get it done within a reasonable amount of time?
I have
So-
two guys that have installed two 490s. They started at 6 o'clock in the morning and they finished it at 8 o'clock, but they had a lot more conduit work than what you saw here. There were three guys that did two installation. I was very impressed. I didn't think that they would get it done on the same day. It was in Scottsdale Forum in Arizona. That was a huge, huge install. And they did it in one day. But the prep work, they spent all day the previous day making sure they had everything, but they're very tired at 8 o'clock. Here, I bought them lunch and took them out to lunch at 2 o'clock because I like to see this. You see, on a Sunday afternoon, there is hardly any load, and it was running at 94.9% power factor, and it took it to 0.999. And here is the verification on the MPTS. So you got two sets of data matching up, and the third set is the utility meter. So that's how you verify billing errors. That's the third element of the MPTS. So is this good for now? Where to connect the MPTS, how to connect the power to the MPTS, what it looks like when it is connected. So
Yeah,
You
so
might mention that's on two chillers too. Each one of those is serving a chiller in that
that's
building.
right, because it's all redundant. Remember, they cannot be without AC, they cannot be without power. So this building has to be on all the time.
That's in Spokane, Washington, where they don't need much HVAC actually, till now.
So here is your schematic that shows that this switch, this MCCB, many times it's available in the switchgear, like you have in Casa's church, Dave.
Mhm.
You have a 400 amp MCCB or a disconnect in part of the switchgear.
Right.
So in which case you don't need the disconnect switch. You simply tap here and just take it to the MPTS. That's it.
Right.
And this is the termination box for your CT wires to come. It goes inside here. And then your metering is on the MPTS unit. Another way to look at it is from the outside. This is what it's going to look like. Any questions? Is this clear for all of you? You see there's 208 volt transformer here. There's 480 volts coming in, 600 amps. There's a pumping station. And then they have a transformer to keep this room clean with full of VFDs. One VFD is already blown. That is why they put an MPTS to protect the other VFD, because it's a 3,000 feet deep well motor. They cannot afford for it to go down.
3,000 feet deep.
So they already lost the redundant motor and the VFD, it's gone.
so that's really good. If I could, Adil, I'd like to kind of just recap a little bit on the information that I've noted down here today.
Sure.
You know, kind of starting all the way back from, you know, it is important that when you receive the unit, that of course you inspect it for any damages, note immediately if there's damages, so shippers can cover any damages with insurance. Having the considerations to move and store the unit. You mentioned that the lightest unit is 900 pounds and it only goes up from there up to 2,000 pounds. That you have done many installations on casters and had it approved by the inspectors, but only understanding that if you are in seismic areas, or if you just want to check with the inspector beforehand, that casters is an option as opposed to bolting it down to a surface.
Yep.
Make sure you get the proper configurations, 3-wire or 4-wire. Is that has to be specified upon ordering the equipment, correct?
Not
Uh,
necessary because the equipment is now designed to operate in 3-wire or 4-wire environments.
Okay, so to clarify, you said it can do 3-wire or 4-wire, and it is not a separate piece of equipment that needs to be ordered.
No, that's
Okay.
correct.
And then a lot of this, you really did emphasize on the CTs and making sure that you get your power metering installed correctly. I thought it was interesting that the CTs are customer supplied, but after thinking about that, that makes a lot of sense because every electrical installation is going to be unique as far as the needs for the CTs, as far as
Right,
how
right.
big the CTs are, the length of the lead wires coming off the CTs has to be considered so that you're not splicing them. And then going over those problems with the installation of that Accu Energy integrator, that was really good, especially pointing out to us that you've got to be very careful about the phase configuration coming into the integrator and out of the integrator, as well as the polarity of your CTs.
Correct.
Making sure the installer understands how the CTs work and what proper installation is.
Correct.
Now, a lot of CTs that I've encountered do not come with shielding. Is it recommended by you that you get an CT that does have shielding because the integrator actually allows a terminal for that shield?
Actually, it's just a protection for the integrator kit, because if your integrator has enough static energy and doesn't have a ground wire, then you could lose your integrator kit. And if you lose the integrator, then you lose the power management data. And if you lose the power management data, MPTS doesn't know what to do because everything is reliant on the data supplied to the MPTS.
Okay, well, that's understandable. So using shielding and grounding is going to be recommended. And especially if you talk to Carl Keller about that, he'll tell you ground everything very robustly.
That's right.
Right.
But
The
there are
same.
units working in the world where the shield has been ignored, especially in United States. I find installations not to match recommendations or the code. But rest of the world, including Africa or even South America, they take this very seriously and meticulously. So we don't have the problems that we have in the United States in other continents of the world.
That's interesting information. That's because we probably have a lot more installations here in the United States.
Also, we have shortcuts and we want to go fishing and we are focused on vacations, whereas the rest of the world, survival is the key. Nothing is more important to them than their job. If they do something wrong and they lose their job, guess what? They may not get another job.
Good point.
Yeah, that is a good point.
Yep.
So the CTs, you have actually witnessed a couple of installations of CTs in the incorrect locations, and that is why it's very important to make sure somebody's qualified to install those CTs into the correct position and properly route the CT leads to the Accu Energy.
Correct.
Making sure that you've got 2 sets of CTs that are going to be upstream or on the source side of the point of common coupling. And then there's going to be, there will not be CTs on the downstream of the point of common coupling because those CTs are located within the MPTS.
Correct.
Okay.
Do you see this particular screen I have on right now?
Yep.
You're summarizing the whole thing. So this one slide pretty much summarizes the complete installing process.
Okay. Yeah. Well, that's what I'm best at, Adil.
Keep going, keep going. Yeah.
So other things that I picked up is make sure you have a power source for your integrator. You're gonna just need a 120 volt circuit
Yeah.
somewhere run to the integrator unit so that that can be powered up. And then when you get to your point of common coupling, of course, you're going to have to use a disconnect means between the MPTS and the source power so that you can meet the local code. With that, I do have a question. So do all MPTSs have that disconnecting switch handle that I'm seeing right now on your screen?
Yes.
As that one's opened up, that MPTS has a switch on it.
Yes.
So it can be considered as a disconnect switch depending on
Yes.
the inspector.
No, I use the word inspector incorrectly. According to code, you need that. And according to code, if you install the MPTS beside your switchgear and it is within line of sight, you don't need another disconnect or you don't need another MCCB like it is shown here. Let's say this is your switchgear and the MPTS are in the same room. You can tap power straight from the bus bar and connect it here because it's line of sight, because you can lock this up and work right there.
Understood. And that would be something, it would probably be best for installers just to check with the local authority and the inspectors at their site to confirm that they are okay with that.
Yeah, but you and I will always recommend that you have this MCCB that is shown on this sheet that is providing power to the MPTS so that you have overcurrent protection inside the MPTS for, I think, 20,000 amps or 60,000 amps. Whereas this MCCB is another delayed, it is a few seconds delayed, but it is a second set of protection. If something happens, you need that only if something happens inside the MPTS, you got to make sure that it doesn't go into the building.
Okay. And then also looking at the connections for the installers that are actually going to be physically installing it, understanding that as those leads come into the MPTS, it looks to me like they are landing on chair lugs directly above that switch.
Breaker, yeah.
Okay. And of course, the enclosure is going to require that you knock out to whatever size raceway that you're bringing into the enclosure.
Yeah.
And other than that, there's really no other tools necessary besides screwdrivers.
Yeah.
And anything to install supports and racking.
Here's
Say,
another
Brian?
here's another picture which I think is a very clean installation. It's another factory. Again, they got the struts. The AccuEnergy unit, this is what we want Javier to install it like right now, because this gives room for watching what is happening. And then MPTS arrives and they install the MPTS. You continue, and then you continue to see the change in voltage, current, power factor, kVA, kW, kVAR, and harmonics. You have a before MPTS and after MPTS, a beautiful graph that you can see.
Yeah. And I think
Javier, are
that
you online?
Yeah,
Yeah.
I'm here.
So Javier, you have this meter already there. So we need to get this meter installed so that you already are tracking and you're confirming all the parameters in the location where you're installing. And then you are preparing yourself for your settings in the MPTS integrator.
Yep.
What if you thought it was 500 amps and then we see that it is going at the peak current is going to 550 or 600 amps?
Yeah, that's what I was thinking, but I don't think it's gonna be the case. But yeah, we're gonna be able to check that ahead of time.
And not only that, people like Chad like measurement and verification before and after.
Yep.
I think that's going to be universal across the board. Everybody is purchasing this unit because they do want to see some change in their power or the performance of the power at their facility. So getting before and after measurements, I think is essential to ensuring that the customer understands that they have got a good product.
That's right. Good point.
Do you have any more scenarios of what has gone wrong in the past with installations? You've covered many, specifically people doing 3 attempts at getting positioning of the CTs, wiring mistakes such as polarity on CTs, mixing up terminals on the integrator, you said is a common issue. Anything else that you can really recall that a situation didn't exactly go as planned and it costed a lot more time, energy, and money
Yes.
than anticipated?
There was one installation in Phoenix long time ago, 2008 or 2009, where I don't know if you're able to see this clearly. I want to move this picture. This is a good picture. How do I move it to the right here? Okay. Are you able to see these separators here between brown, orange, and yellow? These are insulators, insulator sheets.
Yes, I can see those clearly.
Javier and Chad, this is very important. You see this? This is supplied by the factory now, because in 2009 or 2010, we had an arc flash because the installers had this 45-degree lugs that they did not install 45-degree lugs. They installed straight lugs coming from the breaker and terminated the wire, and the wires were too close. So it created an arc flash. So the electricity, the voltage jumped from one to another.
Right.
Was that in a location that had lots of dust accumulation?
No, this was brand new at the time of installation. They installed it and turned it on, and boom, everything tripped.
That was just because the lugs were not 45-degree lugs, or
No,
I know
they
were
just
too close.
They were too close.
Okay. So now
Yes.
does the MPTS come with the insulating plates, the isolator plates standard? Or
Yeah.
is that something we have to add in the field?
No, it is there.
Okay.
In fact,
Thank you.
the lugs now should be coming in with 45 degrees, so they're spaced out farther apart. But that is a field item, part of electrical supplies. Usually the electricians have it in their truck or in their toolkit. And then they need to, if they splice it, they need to make sure that they have the proper termination connector to crimp it onto the brown wire, and then it is bolted in with no loose contact. Those arc flashes happen only when there's a loose contact and something is too close.
Bill, is there a spec on the distance between them? Is there a spec on that?
Yeah. That is in their code book.
Okay.
Yeah, Dave, I believe for 480 volts, minimum clearance is, I think, 1 inch.
Okay.
We provide more than 1 inch because the breaker provides the distance that Dave brought up. Okay. But what happens is they are providing that 1 inch distance, thinking that the wire is going to go inside the breaker. There is no exposed metal outside the breaker. But the moment you are bringing the connection outside the breaker, now you got to be cautious. That was an extremely good question.
Is
What other problems can I think of?
What about environmental problems? So a lot of manufacturing will have lots of dust, debris floating around in the air. I can tell that is a NEMA 1 enclosure, so it needs to be provided with a pretty dust-free environment upon installation.
Actually, if you have just regular dust, which is mud, or just the dust particles flying around, I've not had a dust issue anywhere that created a problem. Dust from a engineering point of view is actually a good insulator as long as it does not have minerals in it. Because dust particles that are flying around usually don't have minerals. But I am in a chemical plant situation where I'm seeing erosion. Erosion of your connections.
Corrosion, okay.
Erosions.
yeah, corrosion.
Mhm.
Yeah.
And fortunately,
Yeah.
I haven't seen it inside the MPTS, but I've seen it outside the MPTS. So far it's holding out okay.
What kind of chemicals are they? And acids?
I mean, these are, I don't want to mention it here online. I'll take it offline. So,
Okay. All right.
yeah. But now this is the last slide. And with that, I will stop recording. You can see multiple MPTS units are installed in a single circuit, and you can create this kind of a scenario in any electrical network. And because MPTS acts like a ground rod sitting on top of the ground, it is better you have more than one MPTS if your network load permits, because you want more than one point to remove harmonics, because harmonics is the greatest threat today for power quality in electrical.
Thank you, Deal. I have to jump. But thank you very much for this. This was very helpful.
Take care, Chad.